Okay. For part 4 of the experiment, when we are talking about the amines, can you tell me what is the difference between solubility of carboxylic acid and solubility of the amines? You took a screenshot of the board when I was talking about solubility, right? Reactions that it have occurred between carboxylic acid and sodium hydroxide, and then we had reactions that happening between amines and hydrochloric acid. So we could have the solubility. I'm just talking about solubility of the amines versus, you could look at page 183 or ebook 181, and that is showing the solubility of the amines. Solubility amines, if they have less than 5 carbon, they dissolve in water. But if they have more than 5 carbon, they don't dissolve in water. They don't dissolve in sodium hydroxide, but they do dissolve in HCl, because amine is a base. It reacts with the acid and it gives the chloride salt of the amine, which is going to be soluble in water. So based on solubility test, you can find out if the compound is amine or not. Now, when you find the compound is amine, then you cannot just stop there. You have to make sure that your amine, is it primary amine, a secondary amine, or tertiary amine. So it depends on how many carbon nitrogen bond you have. You could have primary, secondary, or tertiary amines. So if the nitrogen is NH2, that's primary amine. So you can count also number of hydrogens attached to it. If it's NH2 attached to carbon is primary. If it's NH attached to 2 alkyl group, it would be secondary. If there is no NH and it's just nitrogen attached to 3 R group or 3 carbon, is going to be tertiary. Just like primary, secondary, tertiary alcohol, that they had different specific reactions for classification. Amines also, they have different set of reactions. There is different reactions that we can use to determine if the amine is a primary, secondary, or tertiary. On page 218 in the hard copy, you have the Hingsberg test. The Hingsberg test is going to, based on the reagent that you're adding for Hingsberg test, you can see if you have primary, secondary, or tertiary amine. I want you to bring the chart on page 219 hard copy or 217 ebook and look at the chart with me. Okay, if based on the solubility you decide that your compound is amine, it can be a primary amine, a secondary amine, or a tertiary amine. Then, using the Hingsberg test, you can identify, is it going to be primary amine, secondary, or tertiary? Because that's what we are trying to find out. If it's not amine, let's say if it's carboxylic acid, it's going to dissolve in sodium hydroxide, then dissolves in sodium bicarbonate. So if my unknown is carboxylic acid, I know based on the solubility, if it dissolves in sodium hydroxide, then I know that it's not going to be amine. If it's amine, will not dissolve in sodium hydroxide, it will dissolve in HCl. So after we know the functional group is amine, we do Hingsberg test. For the Hingsberg test, if you follow it on your chart, probably is more clear. So you are going to add for the Hingsberg test, you are going to add the 10 milliliters of the potassium hydroxide, 0.2 milliliter or about 4 drops of the amine, and you're going to add 0.7 milliliter of your reagent. And when you add your reagent and you shake it well, if it forms one layer, and you have to follow this chart carefully, If it's one layer, right away, you know that that layer is going to be a primary amine. Okay, one layer is going to be primary amine. If it's two layers, if it forms two layers, based on it's going to be either secondary or tertiary. Now, when you have the two layers, so if it's one layer, you don't even have to add the HCl, because one layer, it means that you have primary amine. If it gives you two layers, with the two layers, you are going to add HCl. If it dissolves, it's tertiary. If it doesn't dissolve, it's going to be secondary amine. So first, you add your reagent for Hingsberg test. If it's one layer, it's primary, and you are going to stop there. It doesn't say clear. It doesn't say precipitate. It's just saying one layer or two layer. If it's one layer, you're going to stop there, and you say that your amine is a primary amine. If it's two layer, it could be tertiary or secondary. How do you know it's tertiary or secondary? You're going to add HCl. When you add HCl, if it changes to one layer, basically if the precipitate dissolves, or if it changes to one layer in general, you're going to decide that is a tertiary. If it stays as a two layer, it's going to, the conclusion is that that is going to be a secondary amine. So we do solubility test, and we are going to test the, with the Hingsberg test. I hope that we get the answers for the Hingsberg test to find out, to make sure that we can distinguish between primary, secondary, and tertiary. Carboxylic acid. How do you know you have a carboxylic acid based on solubility test? How do you know you have a carboxylic acid based on solubility test? Can you hear me? Yes? Okay. Based on the pH, it dissolves in water. All carboxylic acid would dissolve in water. Solubility test. Based on solubility test, how would you know you have carboxylic acid? Okay, solubility test. Based on the solubility test, if the compound dissolves in water, it could be any polar compound. It could be ketone, aldehyde, alcohol, or carboxylic acid with less than 5 carbon. If it doesn't dissolve, then you don't know what your compound is. You have to continue with the solubility test. Your next step is adding sodium hydroxide. So when you add sodium hydroxide, if your compound dissolves, then you can say your compound is either carboxylic acid or phenol. And next step, you have to do the sodium hydroxide test. And with the sodium hydroxide test, you could say if your compound is, with the sodium bicarbonate. With sodium bicarbonate, if the compound is carboxylic acid, would dissolve in the sodium bicarbonate. But if it's not carboxylic acid, if it's phenol, it will not dissolve in sodium bicarbonate. If you know you have a carboxylic acid, in order to find which carboxylic acid is that, is it acetic acid, is it hexanoic acid, is it benzoic acid, what type, benzylic acid, what type of carboxylic acid you have, then, or what's the name of carboxylic acid, all you can do is just find the molar mass for the carboxylic acid. When you have the molar mass, based on the molar mass, you can decide the structure of the carboxylic acid. you can at least narrow down, and then if you have a solid compound with the boiling point or melting point with the liquid boiling point, you can narrow down your carboxylic acid and find the name for it, because you have the molar mass and you have either melting point or boiling point. You don't have to do derivatization for carboxylic acid. Titration is going to replace the derivatization for carboxylic acid. If you have aldehyde or ketone, you have to do derivatization. But for carboxylic acid, you could only do titration, and then you find the equivalence point. You find the equivalence point. You are using indicator to find the equivalence point, and then based on the equivalence point, you can calculate the molar mass. 3 steps on page 221. It shows how to calculate the molar mass. So first you're going to find number of moles of the base, which is the milliliter of the base times the concentration of the base. So concentration times volume in liter, that would give you number of moles of the base used. Number of moles of the base equal to number of moles of the acid. And if you have the moles of the acid and you have mass of the acid, you can calculate the molar mass. So basically, mass of the acid divided by number of moles will give you the molar mass for your acid. And based on the molar mass, you can find out which acid you are dealing with. So silver nitrate precipitates with most acids. Unfortunately, based on my experience, even though I have the procedure here, is not a reliable test to confirm that you do not have carboxylic acid. But if you get a positive test, you do have definitely. So the positive is strong. So if you get a positive test with silver nitrate, it's definitely carboxylic acid. But if you get negative tests, you cannot deny it. You cannot say it's not carboxylic acid. So if it dissolves in sodium bicarbonate, carboxylic acid is the only compound that dissolves in sodium bicarbonate. So if it dissolves in sodium hydroxide and specifically in sodium bicarbonate, your compound is carboxylic acid. Okay. Procedure for the experiment. We are going to do the carboxylic acid experiment first. Okay, and then I'm going to test for the amines also. So carboxylic acid, for solubility tests, we are going to test for solubility test first. So I need your help to tell me which solvent should I use for my solubility test. Which solvent? What should I use for solubility test? I'm going to do the experiment. We're moving to gonna grab my safety glasses. I also got some large test tubes because with the 5 milliliter solvent, it's not easy to shake it when it's small test tubes. So Okay, which solvent? Water, 5% sodium bicarbonate, and 5% of sodium hydroxide. Okay, about 0.1 gram of the sample with like a tip of a spatula, and we will talk about tip of the spatula is actually tip of a spatula, very small amount. And if we use more than tip of a spatula or 0.1 gram with the 5 milliliter of the solvent, it can saturate the solution. If the solution is saturated, then it's not going to be easy to recognize if it's going to be if it's soluble or not. So the first compound that I use now is the benzoic acid. Okay, for benzoic acid and water, benzoic acid and water, and I'm going to shake it well and see if it dissolves or not. Do you see the particles on top? If it did dissolve, it would have disappeared, but since we have those particles on the floating, means that the compound is not soluble in water. So next, okay, if you're using this type of spatula, see, if you fill it up to the end of this triangle cut that you have for the spatula, that's like a full spatula. Half a spatula is like halfway. When I say tip of a spatula is just about 1/10 of it, so very small amount. It's not full spatula or half a spatula. So you're going to add tip of a spatula, a small amount, into the test tube. And this time, we are adding sodium hydroxide. 5 milliliters of sodium hydroxide, and we mix it. Water, sodium hydroxide. You see the difference? And you can take a screenshot of this. Solubility of carboxylic acid in benzoic acid, specifically in water, in sodium hydroxide. Okay. And the next step is benzoic acid in sodium bicarbonate. Benzoic acid in sodium bicarbonate. To go back to experiment 18, when I was talking about solubility of carboxylic acid and the reaction I had on the board for you, I said if you mix it well and you hold it, you might see formation of bubbles. You see those bubbles are forming now actually. Okay, the bubbles are forming. That means it is reacting. And if I wait long enough, this is going to actually disappear because the weak base, so it is dissolving, but dissolving slowly. But if you see the size of the bubbles are changing now, because those new gas is producing, that means the reaction is actually taking place and carbon dioxide has been released. See, those are the bubbles. So when you see those bubbles, that means you have carboxylic acid as the unknown. We already know it's the carboxylic acid. So it's the idea just to check for evidence of the reaction to see you have the carboxylic acid. After the solubility, we test with silver nitrate. With the silver nitrate test, we want to, what's the procedure? A small sample of the acid and we are going to add ethanol to dissolve. So we take a small sample of benzoic acid. Going to add the ethanol to dissolve. Stopper with the cork, mix it well, and until it's dissolved and I get the clear solution. What would be the next step? What's the next step? I finished the solubilities. It was solubility in water, solubility in sodium hydroxide, and then solubility in sodium bicarbonate where I showed you the bubbles. Just for benzoic acid, yes. Just for benzoic acid. And then I'm doing now repeating the same experiment for, or performing the experiment for benzoic acid and silver nitrate, and I want to see if it's going to work or not. Testing for silver nitrate test. I added the sample of solid, small amount of the solid. I dissolved in ethanol. What is my next step? If you look at your lab notebook, you should have it because you wrote the procedure, right? Silver nitrate test. Tell me what to do. If I'm too fast, you tell me what to do, and then I'm going to follow your procedure. Okay. Add 2 milliliters of silver nitrate. Okay. And mix it. Because I had my sample already. I dissolved in ethanol. Now I need to add the silver nitrate. So 2 milliliters is about 40 drops. So I'm adding about 40 drops of the silver nitrate. Okay. I have 40 drops now. I have to close the container. Going to cap it with the using a cork. Mix it well and look for any precipitate. It's turning slightly cloudy for the precipitate. See some particles. I'm not sure how clear it is for you. Can you see any particles? I have some white particles floating. Then, as I told you earlier, for silver nitrate, I haven't had best result, but if it's positive, definitely it's carboxylic acid. If it's negative, we cannot say it's not carboxylic acid. So we have to make sure that we have the solubility test as a backup. Adding more silver nitrate, hoping that I get more precipitate. So this way you can actually see the cloudy particles. How is this not working? some more of the silver nitrate. Should be able to see the precipitate. You asked me to slow down, and this experiment is making us very slow. So you probably want to now have to move to the next step. Are you still in the same? Okay. Do you see some precipitate that formed here or no? When I'm mixing, you could see the particles. Can you see the particles now? Okay. Kind of. That's all we had. So we have the small particles that is forming, and if you pay attention, you could see those flakes moving. Okay. The precipitate that formed. You could record that as a silver nitrate test. Do you all know which part of the experiment we were doing right now? I repeated at least like 5 times. Silver nitrate test. Yes, okay. And if you look at the procedure for silver nitrate test, silver nitrate with benzoic acid, very good. Procedure for silver nitrate and benzoic acid is on page 222. An ebook would be 2 pages down, so 220. There is no sodium bicarbonate involved in that reaction. It's just the acid and silver nitrate. And all we do, we add ethanol to dissolve it. So the reaction is the reaction between carboxylic acid and the silver nitrate. The product that is forming, we didn't get too much of product, but that amount of product that you saw, and if you review the video later, I'm going to post it this afternoon. You could see the flakes, some powder that it formed, and that was the silver carboxylate precipitate. Silver carboxylate precipitate. Okay. We did not add the HNO3. When we add the HNO3, that is to make it clear again. You can add the HNO3. Can you look at the page 221, chemical reaction, and tell me why adding of HNO3, is going to dissolve the precipitate? Can you tell me that? Addition of HNO3. Either on page 221, hard copy, or 219. All you do, just look for the reaction between carboxylic acid and silver nitrate. You're changing the reaction from product side to the reactant. So basically, if you're adding extra HNO3, it's going to take the reaction and shift the reaction back. Okay. So this is after adding HNO3. It's all clear now. Okay? After adding HNO3, it's all clear. Wait. But the precipitate dissolved here. I'm glad before starting this experiment, I told you that silver nitrate is not a reliable test for most of the acid. I guess I picked the benzoic acid, which was the wrong choice, and is not following what it should be. What is written in the manual is correct though, okay? If it stays a precipitate, it's the carboxylic acid. It's not the most reliable. For some of the acid, it did not work in the past. And if you go back to beginning of the recording, I had this problem before also. It didn't work. It didn't always work. It turns like cloudy, and then it stays there. I don't see a precipitate now at all after adding HNO3. It was supposed to form precipitate. It's not as clear as water. See? If you compare with the water, it's not as clear as water. It's slightly cloudy, but I don't see like solid precipitate after adding HNO3. It's just cloudy. I don't know. Can you see it as a cloudy or is not cloudy for you at all? Slightly cloudy, okay, but it's not very strong. Okay, it's not very strong though. When you compare with the blank, which is the water, it makes it easier for you to see it's cloudy, but it's not the best, and it's not the fastest. It's not like adding 2,4-dinitro you did for the other aldehydes and ketone yesterday, and you saw the precipitate right away. Okay, so it is more cloudy than the water, but doesn't have like a solid pieces. This is after adding HNO3. You could record this observation because in the lab we cannot change what we see. We record the observation as a result of the experiment, whatever they are. So I don't know if I like to see it cloudy as a precipitate or is actually cloudy, but you record your own evidence. What do you think it is? Okay. Yes, to me, like if I'm holding even this way, it looks cloudy. It looks cloudy now. Silver nitrate leaves black stain for a long time, so I touch that solution that contains silver nitrate. I had to wash it right away, and if it happens to you, you should wash it right away because if it stays on your skin, it will leave black stain for a long time. Yes, that is the positive test. If the precipitate does not dissolve and it stays cloudy, that is the positive test. Okay. It has not dissolved yet, so we can do that. Okay. You can record it as part of it. Remember yesterday, one of the test tubes, this has nothing to do with today's experiment though. Don't get confused. Please don't get confused. This is from yesterday. I saved it because the yellow precipitate was not forming for acetophenone, and I didn't want to just discard it and say, well, it didn't happen. And it's a little cloudy, and that cloudy part is the iodoform positive test that is forming. So we were looking for a precipitate for cloudy solution, and that's what we have. A cloudy solution. This is from yesterday. It's not today's experiment for acetophenone, and I wanted to keep it and show it to you today if it happens or if it did turn cloudy. Okay? If you don't have your lab reports written already, you can add it. This is the iodoform for acetophenone from yesterday. Positive test. Yes, it is positive test. Okay. Next part for the experiments with the benzoic acid is next one is titration, right? How do we do titration? Help me with the titration procedure. What should I do first? Set up a burette, okay? I always like to make sure that the burette is working, so I add some water and drain it to make sure it's working. Good. What is next step? 0.2 grams of carboxylic acid. I'm going to continue using benzoic acid. Using benzoic acid, getting 0.2 grams of the acid. That is very tiny. 0.2. 0.2 grams. Easier on the paper. Dissolve in 50 milliliters of ethanol. Okay, let me make sure I have the 0.2 grams first. I got 0.202 grams. going to add to a flask. I have to measure 50, but they gave me 25 milliliter graduate cylinders. I have to do 2 times. Okay. 50 milliliters of ethanol. And you said 3 drops of phenolphthalein. So my solution is ready. What should I do next? With 0.1 molar sodium hydroxide, this sodium hydroxide is not the sodium hydroxide we make here. We actually buy the standard for this titration to make sure we don't have to standardize the solution after we make it, so it's more accurate, basically. To fill up the burette with sodium hydroxide, going to drain some to make it align with the zero line. Okay. You can bring this down to see if it's the meniscus should be at 0. When it's set at exactly 0, I can start my titration. The acid has dissolved. In ethanol, I have the phenolphthalein, and I'm going to start the titration. The white background to I keep adding and swirling. If I bring the computer closer, the camera, you might see that the pink color in the center, it appears and it appears. See the pink color? It's in the center. I'm going to add enough until the pink color stays for 20 seconds. Okay. 18.1. The volume is, it goes from 0 . Basically, this is 0.6. It turned slightly more pink than what I wanted. So it could have been like 18 and I got the 18.1 0. So we find out when we calculate when you calculate the molar mass, it is slightly different than the molar mass for benzoic acid. You can explain in your conclusion the dark color that you got for titration. Any questions about the equivalence point? For practice, because the idea is to see how benzoic acid or carboxylic acid in general is going to dissolve in water or not, if it's going to dissolve with sodium hydroxide or not, and then if it does dissolve in sodium hydroxide, then we test with sodium bicarbonate. The reaction with sodium bicarbonate is slower, but when you see those bubbles that is forming, that means it's dissolving or the reaction is taking place. I still have it in the test tube rack, and I'm going to show you later that it's completely dissolved in sodium bicarbonate. It just takes longer time. You either have to wait long time or you have to look for formation of the bubbles. But if the bubbles form, that means H2CO3, which is carbonic acid, has produced in the chemical reaction, and carbonic acid is not stable. It decomposes to H2O and CO2, and you see those bubbles of CO2, and that's indication that the compound dissolved in or reacted with sodium bicarbonate. With the benzylic acid, which part do you want me to perform with the benzylic acid? When we have groups of 2 or 3 working in the lab, I usually ask each person performs one of those experiments, so you get to actually practice with the using of the setup, being able to set up. But for me to as one person, if I had a group of one or individual work, I would ask for one as a practice. Sure. For the data table, you're using the benzoic acid, yes. So the result of benzoic acid, you would use that for your data table, yes. So we know which experiment we've done in the lab. Okay. Any other questions about carboxylic acid experiment? No? We just my hands one more time. Okay. The sample for sodium bicarbonate has not solved yet, but is much less than what I started with. I put a little too much acid for sodium bicarbonate because I wanted to see faster reaction. So you could see the bubbles are forming. So that's why it still is not dissolved, because I put too much of the acid, but I'm going to save it and show you before we leave the lab today. I'm going to show you that has dissolved because it is reacting and it's still forming bubbles on top. That means it still is reacting, but it's much less than what I started with. Next part of the experiment of amines. Which experiment are we doing for amines? Are we doing solubility as well? Water, hydrochloric acid, and sodium hydroxide. Okay. Going to watch for test tips, some of the test tips I can use for the DI water, so I don't carry over. Solubility and Hingsberg test. Okay, for solubility, I can one of the amines or all three of them, but for Hingsberg, we have to do all three of them, okay? For solubility, first solubility would be in water. 5 drops of the amine, and I added water. The amine that I'm using is the sec-butylamine. So amine with 4 carbon, amine with 4 carbon, completely dissolved in water. This is not a, it's a good example for amines that they have less than 5 carbon, they dissolve in water. But I won't be able to use the sodium hydroxide or HCl for this one because it dissolves. If it dissolves in water, it dissolves in sodium hydroxide, it dissolves in HCl, and it doesn't give me valid answers. So all I can say that this is a polar compound with less than 5 carbon, and it does make sense. If you have sec-butylamine, it will dissolve in water. And for this amine, you should not continue with sodium hydroxide or HCl. So another amine, a secondary amine of, this was the primary amine, but the reason it dissolved is not because it's secondary, it's because it has less than 5 carbon. Okay. Next one. Methylaniline, methylaniline, and water. What do you see? Dissolved or not? No. Methylaniline with water did not dissolve. Another one, dimethylanilene. A screenshot. Okay. I will give you one example. You see, you can get the screenshot. Okay. You can take a screenshot because you have the labels also, right? You see the labels? You take a screenshot. Okay. Methylaniline in sodium hydroxide. Methyl aniline is sodium hydroxide. Okay, not soluble. Methyl aniline is sodium hydroxide, not soluble. Now I'm going to try the methyl aniline in HCl. Okay. In HCl, it dissolved. In sodium hydroxide, did not dissolve. You got it? Yes? Okay. I think that's enough with the solubility, right? The solubility, as long as you know the amines dissolve in HCl, they don't dissolve in sodium hydroxide unless it's less than 5 carbon. Unless it's less than 5 carbon. Okay. One last experiment is the Hingsberg. I have to get more test tubes because these test tubes are small. Okay. Okay, help me with the Hingsberg test because Hingsberg, yeah, it should work. Just that you have to be very careful with the quantity and what you are adding and the steps. Hingsberg, dimethyl aniline would act the same as methyl aniline for water, for sodium hydroxide, and for HCl. Please record that. Not soluble in water, not soluble in sodium hydroxide, but soluble in HCl. Very good. Okay, for Hingsberg test, what should I add? Help me with the Hingsberg test. What should I do first? I'm waiting. 5 milliliters of potassium hydroxide. So I'm going to add 5 milliliters of potassium hydroxide in each of the test tubes. Just letting you know the sample is okay, 0.2 milliliter. Okay. Because my samples are all liquid. That's 5 milliliters of potassium hydroxide in 3 test tubes: primary, secondary, tertiary. Okay, primary, secondary, tertiary. Sorry. And next, you want me to add 0.2 milliliter of amine to each one. So for primary, secondary, and tertiary. 4 drops. 1, 2, 3, 4 drops. This is a secondary, 4 drops. Was it 4 or 5? 4 drops. And then for dimethyl aniline, also 4 drops. Okay. Next, benzyl sulfonyl chloride. Okay, 0.7 milliliters of benzyl sulfonyl chloride. That's about 14 drops. Unless I use the Greiger cylinder. It's not calibrated, so it doesn't get to the, there's no line below 1. Okay, so 0.7 drops in each, 0.7 milliliter in each. That's the primary. Going to get the stoppers. Okay, see the one layer, and if you look at the chart, when you get one layer is primary. Okay, one layer for primary. Now for secondary,
Hello, hi.
hi,
Are you recording or?
I'm recording, but let me mute this. Okay. For the so we found about the primary. Now for secondary, I have to add the reagent. Of the benzene sulfonyl chloride. Going to stop her and shake it. What are we looking for the secondary? What do you think will happen with the secondary? Doesn't go in solution. Okay. That's what's happening, right? It doesn't go in solution and you have two layers now. Okay. And for tertiary, what's going to happen for tertiary? Tertiary also two layers? Is that what you have? Two layers for tertiary as well, okay? Two layers. But we want to confirm in case if it's unknown because they both behave the same, didn't go to solution for secondary and tertiary, then we have to do one more step to discriminate between these two to see is it secondary or is tertiary. And how do we confirm it? Add 10% HCl, very good. We have the 5%. Okay, we have 10% of HCl. We want to add 10% HCl until it's acidic. So it's going to take probably a lot of it because we added 5% of, we add 10% of the potassium hydroxide. So it has to, we have to make sure that this is neutral or basic. For tertiary, we are adding HCl. For tertiary is expected to go to solution. So for tertiary, we're going to add the HCl. Mix it well. Let me get a stopper. Mix. If it goes to one layer, it's tertiary. So now it looks like the primary that we had before, right? It goes to one layer. It doesn't say clear, it doesn't say dissolve, but if it goes to one layer, when you add HCl, then it's tertiary. And that's about the Hingsberg test. It is tertiary, yes. That's a good thing. At least it's working. So we know that if we have primary, secondary, or tertiary, how can we distinguish? I promised I will show you the okay, it did dissolve. Okay. Carboxylic acid with sodium bicarbonate after how long? After like 30 minutes, everything is dissolved. So it's a slower reaction. But even if you didn't have to wait for 30 minutes for this reaction takes place, formation of the bubbles, which we had earlier, and it was continuously forming bubbles. Sometimes the bubbles are coming from like shaking, so you get some air into the solid. But when it was continuous formation of bubbles, that means the reaction was taking place. But at this point, after 30 minutes, it completely does and is one layer. So the compound, if it's carboxylic acid, it dissolves in sodium hydroxide, which was a fast reaction. If it's sodium bicarbonate, this was the benzoic acid with sodium bicarbonate. If you look at the video again, it didn't dissolve completely, but it was forming bubbles, and I said recorded as it dissolved. So it's benzoic acid in sodium bicarbonate, but eventually it dissolved. Any questions? Any questions for me? Titration, it shows, is like a 3-step calculation. You need to find the molar mass for your compound. And the formula is given in the part 5, the theory part. It starts with the calculation. There's 3 steps, 1, 2, 3. Find the number of moles, you find the moles of acid, and you find the molar, you find the molar mass for the acid. Okay, let me go find my chair. Sit down, plug in the computer. Then I promise that I'm going to talk about your exam today. What would be what your exam would look like, the type of questions. Okay. Do you have any question about this experiment? You have 2 experiments next week, yes. You have 2 days of the experiment, worth of the experiment. One is preliminary test, which is basically solubility and melting point for your compound. And or if it's liquid, it would be boiling point. And second is, the second week is classification test to confirm the functional group. And after you confirm the functional group, then you are going to find the actual compound based on the evidence. Any other question about today's experiment? No? Okay. Going to stop recording because I'm going to use this just for part 4 and 5 of the experiment 90. I didn't mean to leave the session. I meant to stop the recording. I